Alright, good morning chemistry students. Here are your corrections for ChemQuest 42 moles and reactions. Mole or ratios in equations. Propane is burned in many rural homes for heat in the winter. Below is the balanced equation for the combustion of propane. For each molecule of propane that is burned, there needs to be 5 molecules of oxygen present. And we can tell that because of the coefficient, right? The coefficient on propane is 1 and the coefficient on oxygen is 5. Likewise, if there were a dozen molecules of propane, 5 dozen molecules of oxygen would be required. Similarly, for each mole of propane, 5 moles of oxygen are needed. Also, for each mole of propane burned, 3 moles of carbon dioxide and 4 moles of water are produced. So not only can we interpret this in terms of molecules, okay, that we have 1 molecule of propane reacting with 5 molecules of oxygen to produce 3 molecules of carbon dioxide and 4 molecules of water. We can also interpret this in terms of moles. So 1 mole of propane reacts with 5 moles of oxygen to produce 3 moles of carbon dioxide and 4 moles of water. The numbers of moles of each substance in a chemical equation are related by the ratio of the coefficients of each substance. And that ratio is called a mole ratio. And eventually you'll put it on your helper sheet as some number of moles of A to some number of moles of B. And these numbers that go in front of here, these are the coefficients from your balanced chemical equation. So, note, for questions 1 through 6 refer to the balanced equation for the combustion of propane. So we're going to use this equation up here. Okay. Number 1, how many moles of water are produced when 1.45 moles of propane are combusted? So I start with my given, 1.45 moles of propane. And again, it's really important now that I have my substance. Moles of propane have to go on the bottom. And this is being asked about moles of water. So moles of water go on the top. Okay, we're using dimensional analysis. Now, the numbers here come from my coefficients. So my coefficient on water is 4. My coefficient on propane is 1. So it's 1.45 times 4. And we should have 3 significant figures because these are exact amounts and they don't limit. So it's going to be 5.80 moles of water. How many molecules of water is this? Remember that each mole has 6.02 times 10 to the 23rd molecules. So I like to always start with our given in case we've made a mistake in our calculation. But this first step is going to be the same, using our mole ratio. But now we're going to use another tool from our toolkit that says moles of water to how many molecules of water. And on your toolkit, this is 1 mole is Avogadro's number. So, I'm going to take 1.45, multiply it by 6.022 e to the 23rd, and multiply that by 4. And so I get, again, I'm going to have 3 significant figures. So I'm going to get 3.49 times 10 to the 24th molecules of water. If 2.35 moles of carbon dioxide are produced in a reaction, how many moles of water would be produced? So again, we start with our 2.35 moles of carbon dioxide. Moles of carbon dioxide have to go on the bottom to cross out. We're asking about moles of water, so moles of water go on the top. Again, this is a mole ratio, so I use my coefficient. So my coefficient on water is 4. Sorry, oh yep, it is still there. And my coefficient on carbon dioxide is 3. So 2.35 times 4 divided by 3. And again, I want to use 3 significant figures, so 3.13 moles of water. Number 3. Why is this statement false? If 10 grams of propane burn, you need 50 grams of water. This is false because our coefficients relate our number of particles and our number of moles, not grams. Okay? So to figure out the mass, you'd have to do some math to figure out what mass you need. All right, number 4. If 27.3 moles of carbon dioxide are produced during the combustion of a certain amount of propane, how many moles of propane were combusted? Okay, so this is asking me to take 27.3 moles of carbon dioxide and figure out how many moles of propane that is. So I start with my given, 27.3 moles of carbon dioxide. Moles of carbon dioxide go on the bottom. I'm converting to moles of propane, so that's going to go on the top. Again, my coefficient, so my coefficient on propane is 1. My coefficient on carbon dioxide is 3. So I'm going to do 27.3 divided by 3, because remember I divide by numbers in the denominator. And again, I want 3 safe fakes, so I'm going to write it as 9.10 moles of propane. B says, how many grams of propane was this? Again, I would suggest that we start with our given again, just in case we've made a calculation error. And again, this first step is going to look the same because the tool that I have to use is moles and grams, right? I'm going to use molar mass. So moles of propane go on the bottom. Grams of propane go on the top. 1 mole, and remember to get the grams, this is where we use our periodic table. So we're going to do 3 carbons, 12.011, that's the mass from the periodic table, plus 8 hydrogens, which is 1.0079. So the molar mass of propane is 44.0962. I can just use all those numbers. So I'm going to take that number and I'm going to multiply it by 27.3. And I'm going to take that answer and I'm going to divide it by 3 because 3 is in the denominator. And I want 3 significant figures, so I'm going to say 401 grams of propane. So number 5, because we're still using that same equation, so I'm going to rewrite that equation up here just so I have it. So it's C3H8 plus 5O2 yields 3CO2 plus 4H2O. Okay, so there's my combustion equation again. Number 5 says, if you have 410 grams of propane, and want to know how many grams of oxygen are required to burn it, you can follow these steps. We're not going to worry about these steps. We're going to do this all in one step because you're good math students and because it's simpler that way. So, what do? I still start with my given. Okay, so I'm going to do it kind of down underneath here. So I'm going to start with my given. 410 grams of propane. Now, my only way to change from one substance to another is with my mole ratio. So I know I have to convert grams to moles. Lucky, I have a tool on my toolkit that relates grams and moles. It's called molar mass. This is our molar mass. This is going to be the same as it was over here, so it's 44.0962. from adding up 3 carbons and 8 hydrogens. Oops, sorry about that. Okay. So now I'm in moles. Moles of propane go on the bottom. I want moles of oxygen, so moles of oxygen go on the top. Most of you like to fill in your numbers as you go, so this is my coefficients. Sorry, try to fix that there, that's better. These are my coefficients. So in front of oxygen, my coefficient is 5, and in front of propane, my coefficient is 1. Now, I want grams of oxygen, though, and again, lucky, I have a tool that has moles and grams. It's molar mass. Again, to get the molar mass of oxygen, I'm going to do 2 times 15.999, 31.998. And my units are crossing out, so I'm going to be left with grams of oxygen. So I'm going to take 31.998, multiply that by 5, and multiply that by 410, because all those numbers are in my numerator. I'm going to divide that by my number in my denominator, which is 44.0962. And I want to have only 2 significant figures. 410 actually has 2 significant figures. So I'm going to say it's 150 grams of oxygen. Uh-oh. What did we do? Just give me a second. 410 grams of propane. Our mass of propane. Oh, that mass isn't right. How did we get that for our mass? Yikes. Alright, so we're going to fix our propane mass. That can't be. Because each carbon's, well, let's check. Maybe that's right, maybe that's wrong. So 3 times 12.011 plus 8 times 1.0079. So that's right. Alright. Well, we'll check my math again, but I think it's 150. Well, let's see. 410 times 5 times 31.998 divided by 44.0962. Oh, there we go. I must have put in my calculator wrong the first time. So I want 2 significant figures though, so that's still 1,500 grams of oxygen. See, even your teacher makes mistakes. Okay? But it was putting it in the calculator wrong. Alright, take a look at number 6. Verify that this statement is correct. If 315 grams of propane combusts, then approximately 515 grams of water are produced. So it's the same kind of problem, but now we're going to start with 315 grams of propane. So 315 grams of propane. We're going to use the molar mass of propane to convert grams of propane to moles of propane. And again, our molar mass of propane is 1 and 44.0962. Moles of propane have to go on the bottom. This time we are going to water, so moles of water will be on the top. Using our coefficients, our coefficient on water is 4. Okay. And our coefficient on propane is 1. But I'm in moles of water and I want grams of water. So moles of water goes on the bottom. Grams of water goes on the top. Again, to get my mass of water, I'm going to take 15.999, that's oxygen, plus 2 hydrogens at 1.0079, and I get 18.0148 grams to 1 mole. So, then, to do this hopefully correctly the first time, okay, I'm going to do 315 times 4 times 18.0148, and divide that answer by 44.0962. And we get, again, we should have 3 sig figs, so 515 grams of water, which is exactly what we were expecting. So now we have a new problem. Consider the decomposition of ammonia. If you start with 425 grams of ammonia, how many grams of hydrogen and how many grams of nitrogen can be produced? Sorry, excuse me. First off, recognize this is 2 separate problems. I have to do one problem. It'll be very similar to figure out hydrogen, and then a very similar problem to do nitrogen. It doesn't matter which one you do first. So I'm just going to start with my ammonia. So 425 grams of ammonia. I'm going to fill in all my numbers at the end. Grams of ammonia to moles of ammonia using the molar mass of ammonia. Moles of ammonia to, I'm going to do hydrogen first, so moles of hydrogen. Moles of hydrogen to grams of hydrogen using the molar mass of hydrogen. Now, numbers. My mole ratio is my easy one because I use my coefficient. So my coefficient on hydrogen is 3. And my coefficient for ammonia is 2. Remember, these come from adding up on my periodic table. So for ammonia, it's nitrogen, which is 14.007, plus 3 hydrogens at 1.0079, gives me 17.0307 grams to 1 mole. And then for hydrogen, it's 2 times 1.0079. So I get 2.0158 grams to 1 mole. So now I'm ready to put this in my calculator, hopefully correctly. 425 times 3 times 2.0158 divided by, and I'm going to use parentheses because I have 2 things here, 17.0307 times 2. And again, I want 3 significant figures, so we're going to say 75.5 grams of hydrogen that we produce. Now, the second problem is going to be very similar. I'm still going to start with my given in case I've made a calculation error. And so my molar mass of my ammonia doesn't change. I use my mole ratio for moles of ammonia. This time I'm going to go to moles of nitrogen. Use the molar mass of nitrogen to get it back to grams of nitrogen. Again, this number is easy because these are the coefficients. So nitrogen's coefficient is 1 and ammonia's coefficient is 2. Again, easy numbers 1. For nitrogen, it is 14.007, and there's 2 of them. So that's 28.014. So now I'm ready to do my calculation. So again, I'm going to do 425 times 28.014. Divide that by, and I'm going to use parentheses again, 0307 times 2. And I want to have 3 significant figures, so I have 350 with a decimal grams of nitrogen that I produce. So, again, these look very similar to what we did back in Chapter 7. Your teacher even makes mistakes sometimes, but we're going to do them all in one step instead of breaking it into multiple steps like they suggest up here. You just have more chances to make mistakes putting things into your calculator that way. So that is ChemQuest 42. Have a good day. Talk to you tomorrow.